Hello friends, so today we are going to do another question on the Rn method. So to solve this question, we have actually a factorial of 2n divided by n factorial upon n factorial to the power 1 by n. Now if you see carefully, you can see that the terms are in multiplication to the power of 1 by n. We have solved plenty of the questions like this. So we have a common method of solving these questions by taking an x in place of everything, by substituting an x, and then we take log both side, so we get 1 by n out of the power, and we have these terms. This factorial needs to be out of the bracket, and we have n factorial into n factorial. So now we are just gonna write the things that we have. So log, now just simplifying the factorial term to see what we can get. Now simplifying it in a smarter way, we can actually just keep the n factorial out and then just like do it like this, upon n factorial into n factorial. We have actually separated the n factorial and then added one term in each to get a 2n factorial, because we can cancel out the n factorial from both the numerator and the denominator. So now we have 1 by n log n plus 1. Now we can actually write this n factorial also. Let me just write it in the second step, till 2n upon n upon 1 into 2 into 3 till n. So this is n factorial. Now we have 1 by n log of, so now we can actually just separate these terms. So we have 1 plus log n plus 2 upon 2 plus log n plus 3 upon 3 till log 2n upon n. So now further solving this, we have 1 by n. So now these terms are in summation, so we can actually just put the summation over here, but we don't know the r, so let me just not put the summation over here in the first step as it is. Let us just convert it into the r by n form. So now to convert this, we have actually converted this type of sum in the previous question, and some of the question I guess in the second or the third video. We actually just divided this by n for both the numerator and the denominator, so we get thing like this, dividing both the numerator and the denominator by n, and then we do it for all the terms that we have upon 2 by n. And this continues till we get to the log 2n by n upon n by n. So writing this, now we can actually write this into the summation form, where r is equals to 1 and this is n. We can actually just separate these terms and get an r n by n and a 1 by n. So let me just simplify this term for you if it's getting a bit tougher for you. N by n plus 1 by n upon 1 by n. So we get a 1 over here, so 1 plus r by n upon r by n. That is the term that we are going to write here. So we have 1 plus r by n upon r by n in log. Now I'm just going to convert it into the definite integral. So we have a 0 and 1. Now log 1 plus x upon x dx. So now we can actually just separate these terms, so we can get a 0 and 1 log. Instead of applying the by parts over here, I don't prefer by parts over here, because I can see that we can actually just divide the terms and we can get and we can just use the log property, which is like this. So we have actually just converted the thing in this into this by using the log property. Now we need to apply the by parts. Instead of applying the by parts over here, we should consider applying the by parts over here, because it's very easy to apply it over here, and we know the formula that it is x log 1 plus x minus, let me just apply it. I guess I'm doing a lot of shortcuts over here. So this is f1 and this is f2. So just applying it quickly, we can actually just write log of 1 plus x into x minus integration of differentiation of 1 plus x is 1 upon 1 plus x dot x dx. So now we get x log 1 plus x minus x, and we have a 1 by x in the denominator as well. So let me just first write it like this, and then we can just add a 1 and subtract a 1 from here. So we have x log 1 plus x minus x plus 1 minus 1 upon x plus 1 dx. X log of 1 plus x minus, separating these terms out, we have 1 minus 1 by x plus 1. Wait, let me just write it a bit clearly. Minus 1 upon x plus 1 dx. So we have x log of 1 plus x minus x minus and minus gets plus, so we have log of x plus 1. So now this is the integration of the term we had over here, and the term we have over here. We actually know the derivative integration of this term because it is very easy. So we can just write it as x log x minus x. So I'm just gonna write it as x log of 1 plus x minus x plus log of x plus 1, and we have a minus sign in between. So x log x plus x from 0 to 1. Now putting 1, we have log 2 minus 1 plus log 2 plus 1 over here, and putting the 0 gets all the terms 0, so we have 2 log 2 as the answer. But we know that this is log x. We have actually considered log x to be this, so we just need to write the log x as 2 log 2. So log x is equals to log 2 to the power 2, so x is equals to 2 to the power 2, which is 4. So this is our final answer. Thanks for watching.